Okay, now what I'm going to do here now is, if you can see it, is I'm just going to continue on again with the perpendicular distance from a point to a line, right? Just taking it a little bit, moving on to another few questions on it. So find the value of k if the distance from the point 3k to the lines 3x minus 4y plus 7 is 6 units. So here, right, let's just assume that I have a line that's going like this, and I have a point here, and the point is 3k. Now, the perpendicular distance from that point to the line is called d. What is the line? It's 3x minus 4y plus 7 equals 0. So the perpendicular distance from the point to the line formula would be what I would normally use to get this distance here, d. But I have been told that d is 6. And I'm asked instead to find k. So really what I'm doing is I'm working backwards. So I'm still using the same formula. If I got the perpendicular distance from 3k to the line 3x minus 4y plus 7 equals 0, I know that it is 6 units. So the formula I would have used is ax1 by1 plus c over the square root of a squared plus b squared, and I know I would have gotten 6. So here I have ax by plus c equals 0, x1, y1. Right, so now what do I have? I have 3, filling it in, by 3, which is x1, plus b, which is minus 4, by y, which is k, plus c, which is 7. The modulus of all that, all over the square root of 3 squared and minus 4 squared. And I know that my answer will be 6. So working through that, I have 9 minus 4k plus 7. The modulus of that over the square root of 9 and 16 is 25. Remember, you can put all that in your calculator, but you will never have a negative between the two values. And that's equal to 6. So 9 and 7 is 16 minus 4k modulus all over 6, the square root of 25 is 5, and that's equal to 6. So now I can cross multiply, and I'll get 16 minus 4 times k is equal to 6 5s are 30. Now I must solve that modulus equation. So I'm going to bring it up here, 16 minus 4k. The modulus of that is equal to 30. Now if you will recall from junior cycle maths, right, or from transition year, right, when you will be solving modulus equations, what the modulus means is how far this value is from the origin. Now, right, it's 30 units from the origin, it says, right, so the modulus is 30. That means that it can be 30 units to the left of the origin, which would be all the minus values, or 30 units to the right of the origin, which would be all the positive values. So there's two possible answers. So I draw my line here, and I write down my two possible answers. 16 minus 4k, if I get rid of the modulus, it could be 30 units to the right, which would be plus 30, or 16 minus 4k could be 30 units to the left, which would be minus 30. So when you get rid of your modulus, 16 minus 4k, it's either plus or minus 30. Now the other method that you could use for that would be to square both sides, right? I'm just going to use this method for now. It'll give you the same answer. Right, so minus 4k is equal to 30 minus 16 when you bring it over. Minus 4k is 14, so 4k is minus 14. So k is minus 14 divided by 4 is minus 3.5. Okay, right, on to the next one. Minus 4k is minus 30 minus 16. Minus 4k is minus 46. 4k is 46. So k is 46 all over 4. Now that's about 11.5, isn't it? Right? Now I was told in the question up at the top that k was less than 0. So if k is less than 0, that makes that answer invalid. So this is my valid answer. So k is equal to minus 3.5. Is that okay? That's the first one done now, right? So we move on now to example number 2. That I have, and example number 2 is here, where I'm told, investigate if, right, or investigate whether the points 5 minus 2 and 3 minus 3 whether they lie on the same side of the line 5x minus 4y minus 30 or on the different sides of the line. Now what I mean by that is, if I had a line, right, and my points, 5 minus 2 and 3 minus 3, do they lie on the same side? Are they both above, right? Or maybe they're both below, right, both points? Or do they lie on different sides? Is one above and one below? That's what they're asking you there. So we're going to determine that. Now, how do I determine it? If they lie on the same side of the line, when you get the perpendicular distance from the point to the line, for each one, right, they'll both be either positives or they'll both be negatives. Answers, all right? This one, right, if they are again on the same side of the line, when you get the perpendicular distance from that point to the line and then get the perpendicular distance from that point to the line using your formula, the signs of your answers will be the same. So they'll both be positive or they'll both be negative. The other one here then is if they lie on opposite sides of the line, when you get the perpendicular distance from the point to the line and the perpendicular distance from the point to the line, one will be plus and one will be minus. They won't be both the same for your answer. So I'm going to do that now. Get the perpendicular distance from 5 minus 2 to the line, 5x minus 4y minus 30. Get the perpendicular distance from 3 minus 3 to the line, 5x minus 4y minus 30 equals 0. Now I have this one done already. So 3 minus 3 to the line, ax1 by1 plus c over the square root of a squared plus b squared. When I worked through it, I have my modulus, but I know that a distance is always going to be positive. Now, the reason I don't have my modulus formula here is it's, right, even though we know that a distance will always be positive, right, what we're using for the actual merits of this question, we need to establish whether it's minus or plus. So we drop our modulus just for this question. Now I got a negative 3 over root 41. So it's a negative answer. So let's see what the other one would give me. So for putting into my formula, ax1 by1 plus c. Again, I'm not using the modulus because I want to establish which sign it is. Square root of a squared plus minus 4 squared. Remembering that will definitely be a plus. So 25 plus 8 minus 30 over the square root of 25 and 16. So 25 and 8 is 33, take away 30, and it's 3 over root 41. Now, this answer, 3 over root 41, is a positive answer. So from that point, one is positive and one is negative. So if they are different, we can conclude that 5 minus 2 and 3 minus 3 lie on opposite sides of the line 5x minus 4y minus 30 equals 0. Remember, if they lay on the same side of the line, they would both be positive or both be negative. But because one is positive, one is negative, they lie on opposite sides of the line. All right, so there's a bit there in that. Then I'll move on to the next one, if I can find where I put it. Here, number 3. This is a long one now, right? This whole video, because we're going to get through a bit of content, right? So calculate again the perpendicular distance from the point to the line. Easy done, right? Perpendicular distance formula using ax1 by1 plus c over root a squared plus b squared. So when I do that, straightforward, I got 3 units. All right. Again, taking the modulus, right? Because we know our answer will be positive. Now, the next thing it says, the point minus 1 minus 5, so relevant here because they're in both parts, is equidistant from the lines 3x minus 4y minus 2 and 3x minus 4y plus k, where k is not equal to minus 2. Find the value of k. So what that means is it's equidistant. It's the same distance. We did that once before, right? If it's equidistant, then the distance from minus 1 minus 5 to that line is the same as minus 1 minus 5 to that line. Now I've already worked out how far it is away from this line up above. So I know that it's 3 units to this line. So it must be 3 units to this line, right? So I will now be able to find the value of k, right? It says that minus 1 minus 5 to 3x minus 4y minus 2 equals 0. is the same as minus 1 minus 5 to 3x minus 4y plus k equals 0. The lines are parallel. Remember, 3x minus 4, any line that's parallel to this is of the form 3x minus 4y plus k equals 0. So this is the same as 3x minus 4y plus k equals 0. So they are parallel. So they're parallel lines running in the same direction. We know that the perpendicular distance, so from here to here, is the same as this, which was 3, already established. So this is equal to 3. So what would I have? 3 by minus 1 minus 4 by minus 5 plus k over the square root of 3 squared and minus 4 squared is equal to 3. So now what have I got? Minus 3 plus 20 plus k modulus over the square root of 9 plus 16, never negative, is equal to 3. 20 minus 3 is 17 plus k, the modulus of that, all over the square root of 25, and it's equal to 3. So the modulus of 17 plus k over 5 is equal to 3. Like when we did earlier, the modulus of 17 plus k cross multiply and 5 3s are 15. So to get rid of my modulus, 17 plus k's is equal to 15. Remember what I said, you have one option of squaring both sides, or else the other option is take the positive 15 and leave it equal to, and take the negative 15 and solve it. So what have I got? K is equal to 15 minus 17, so k is minus 2. K is equal to minus 17 minus 15, so k is minus 32. Now, two answers. Go back up and see, was there any restriction on the question? And there was. K is not equal to minus 2. So if k is not equal to minus 2, this answer is invalid and this one is valid. All right? So another variation of those questions. Finally then for today, write down the equation of any line parallel to this line. Remember what we said? If it's parallel, it'll be of the same form. 3x minus 4y plus k equals 0. If it's perpendicular, remember doing this before Easter? Any line perpendicular to this. Interchange the two of these. So the minus 4 goes in front of the x and the plus 3 goes in front of the y, and plus k equals 0. Then as my last step, change the sign in there. Okay, so this is a line perpendicular. Interchange, change the sign, right? So 4x plus 3y minus k equals 0 if you wanted to divide them all by a minus all the ways across, or multiply them by a minus, right? You have to have an equal 0 to be able to do that, right? Now, marking your questions then from your books after that, it is on page, I'll have to find the page, I'd say, oh, maybe I have it here. Right, on page 163, questions 8, 9, 10, 11, 12. Now I'll put them up as well on the as your notes on the Google Classroom. All right, so for tomorrow. Okay, thanks.